Hello 8th graders, and let's prove the Pythagorean theorem. Now we went over this in class, but I want to make a video just as a review in case you need to review any steps. So we're going to prove the Pythagorean theorem using our rules of similarity. So the first thing I'm going to do is draw a right triangle with an altitude that creates three similar triangles. So we have triangle ABC, and I'm going to label my legs A and B, and the hypotenuse is C, and that is a right triangle. I'm then going to draw an altitude, and I'm going to label that H just for the height, and I'm going to label each of these pieces of the hypotenuse X and Y. So what I'm going to do now is I'm going to draw all three triangles separately. So I'm going to draw the big triangle, the medium triangle, and the small triangle. Now, from there, I'm going to color code them so you know what I'm doing. The big one is A, B, and C. The red one, well, we know right here, this is going to be, let's call that point D. So that right angle and the next two are point D, where the right angle is. So here we can see that the short leg on the red one is right here, and that is point CD, or not point CD, that is segment CD. So we're going to put a C there. That makes this one B. Now the blue one, which I'm going to color code as this, we can see that the short leg here is right located here, which is segment AD. So this is going to be triangle ADC. Now we know that all three of these triangles are similar. Why are they similar? Well, they all have a 90-degree angle, but they all share another angle with the whole triangle. So for example, the red triangle here, triangle CDB, shares angle B with the big triangle. So by angle, we know all three of these are going to be similar. So now I'm going to label the sides. The sides are going to be labeled the same as in our big triangle, so I'm just going to label them. This is going to be A, B, C, DB, that's going to be Y, CD is H, and this one, CB, is A. AD is X, DC is H, and AC is B. So what I've done now is I have redrawn them and scaled them down so we have room to work. So here's where you got to start, is we are going to write ratios to the smaller triangles to the big one. Now remember, similarity says that the ratios of sides are the same. So we can write ratios. So what I'm going to do is, since we know Pythagorean theorem is a squared, b squared, and c squared, we're going to use the sides that deal with a and b. So what color do I want? Let's use orange. Orange sounds great. So if we use orange, I'm going to start with the red triangle to the big triangle. So I see here, oh, there's an A. And that A matches up with this side. And then I see an H and a Y. Well, the H and the Y don't help me here. So I'm then going to take the A here and match it up with this. So I'm going to write a ratio for those two sides. I'm going to write C divided by A, which is C, the orange sides, equals A divided by Y. And I cross multiply, that gives me A squared equals CY. Now I'm going to go to the small blue triangle to the big triangle, and I'm going to use B. So B matches up with C, and let's use yellow. I don't use yellow often. B matches up with X. So I then write a ratio for that. That would be B divided by X equals C divided by B. Cross multiply, B squared equals cx. I now just use the addition property. I can just add something, I can just add them together. That gives me a squared plus b squared equals cy plus cx. Well, what do I do now? Well, I can factor out that c. So I can take a squared plus b squared equals c multiplied by y plus x. And by good old substitution, look up here. Oop, we don't have it anymore. Let me bring it back. Hold on. And ta-da, there it appears. Look at what I have for x plus y. X plus y, that's equal to c. That's the whole length. So I basically take a big C, and I substitute it in. So that would be c times c, therefore proving a squared plus b squared equals c squared by similarity. You have a standard that solely proves this on the next assessment.